So it's been a long time. I guess 10 days since my last stream, and it was because I like you know I had fever, and then I went to my convocation, and then the week after that was so you know I won't say it was hectic, but I didn't feel like doing anything. So I just for the whole week I did nothing. Just like YouTube and Instagram and all. Yeah. So after 10 days or maybe 12 days, on the first day of December, so we will again start doing DP questions. Okay, I want to do this problem again. I know last time like I only copied this thing, so this time I also have a whiteboard, so we can write stuff here. I don't have the pen, but I'm sure like this will be fine. I'm sure this is fine. Okay, so again, what does the question say? We have an array that has n integers between 1 and m, and the absolute difference between two adjacent values is at most 1. For example, here this is an input, so 35202. Okay, 35202. Okay, given a description of the array where some values may be unknown, your task is to count the number of arrays that match the description. So we have to count it. So whatever the answer will be, we know that answer will be the summation of dp states, because we have to count it, right? Oh, I'm pretty good at this. I'm using mouse only, you can see. Okay, anyways, okay, so it will be like we will in the end we will add all the possible state answer to our answer. So kind of like this, we can have our dp set to, we can have our dp state like this. Okay, ith position ending with jth number. Okay, okay, so total number of arrays total number of arrays till ith position ending with j. Okay, so this will be like 0th position, we will have all the numbers, whatever is the range 1 and m, right? So of course our dp will be of size what? We have an array of size n, so 1 2 3 4 5. Okay, 10 to the power 5, 1 2 3 4 5, and we have m is what? 100, so 105. This will be our dp. Okay, and base case, if we talk about base case, so there are two cases, right? Okay, what if n is equal to 1? Okay, and the only element that we have in the array is some number that is not 0. Okay, so anything from 1 to m but not 0, or we can have a case where it is 0. Okay, So basically we can have these two cases for 0 if we have only one element in our array, right? So for this the answer is simple, it will be 1 only, because that number is fixed, right? And in this case we can have all the numbers from 1 to m. So everything will have 1 as like every number between that is a possible answer. So what we'll do is we'll just not add it, because our dp is like this, right? So we can just have dp 0 and all the numbers, for example 1 to like your m, we can have it set to 1 only, because all of those numbers are possible answer, right? Okay, so our base case is set. What base case is what? dp we have only one element, so dp of 1, and okay, so there are two cases, right? Let's say x is our array, right? So x0 is equal to, or let's not do it like this, dp how do I write it? Okay, let's just do it like this. We have x0 is not equal to 0, and we have x0 equal to 0, right? There are two cases. If x0 is not equal to 0, in that case we can do dp of 0 base case or 1. Let's just go for dp of 0. Or we can do 1 also. Let's just say dp of 1, and all the numbers 0i is equal to 1, and I will be 1 to m, right? And in this case we can just do it like this, dp of 1 x0, whatever number that is in the first place, and we'll put that as 1. Okay, so what about the transition? Transition also, like for this element, there is for any element we have two options. Same, if it is like not equal to 0, and if it is equal to 0, right? So if it is not equal to 0, in that case we know that to make this element as the ith, to put this element into the ith position, we had to put I minus 1th I or I plus 1th in the previous element, right? What I'm saying is that for example, let's say we have an array 2 3 2, right? We know that for 3 to be here we had to have 2 or 4 here, or 3, right? So to make or total number of arrays ending at this position with the element 3 will be contributed from total number of arrays till I minus 1th ending with 2, 3 or 4. I hope you get my point, because here the absolute difference between the adjacent values at most 1, right? So if it is 3 here, then in the I minus 1th position it has to be 2, 3 or 4, right? So from these values, because it is already calculated, since we are like bottom to up, we are building the solution. So this will contribute to the next that is ith location, and also this three numbers will contribute in the next next answer, basically. So yeah, this is how the transition will be. So if xi is not equal to 0, that is it is fixed, then dp of I and xi right will be dp of I and j, and where j is what, let's just say this is x, so x minus 1, x and x plus 1. Got it? So this is how the this works here. And if it is 0, then in that case we have the option of putting every number, right? So then we can go, move j from, then we can traverse basically loop through all the values. J is equal to 1 to m, and for each value we can for each value we can check, we can not check, not only check, but also we can just do it like this, ith position ending with j. So this will be contributed by, of course, the same as this, the previous position I minus 1. Okay, this is I minus 1, I minus 1, and we have x, where x is nothing but j minus 1, j and j plus 1. Also given that such that x is less than equal to m and x is greater than equal to 1. This is the condition. So now that we have all the transitions and this, let's just jump onto the solution. Again we'll do bits stdc plus h, and using namespace standard int main, let's just do dp here, 1 2 3 4 5 105, and we have what, 35202, right? Okay, n m n x, so n I just take x as input, uh, okay, we have the input, and of course again we'll check if x0 is equal to 0. In that case we can just run a loop for int I is equal to 1 to m. You can just say that dp of 1 I is equal to 1, else dp of 1 x0 is equal to, okay. Okay, so now we'll loop through the array elements from 1, yeah, because we have already processed the first element. I less than equal to n less than equal to less than n, and if x0 or xi, sorry, double equal to 0, then we'll have two options, right? If xi is 0, then what we can do is for int j is equal to 1, j less than equal to n, j plus plus. Again, this is something I learned from the last stream, that we can do it like this: j minus 1, j plus 1. Okay, if k is less than equal to m and k is greater than equal to 1, then what we can do is dp of ij is nothing but dp of I minus 1 k, right? We'll just have it as mod. Not mod will be needed. Int mod is equal to 2 3 4 5 6 7 8 9. I hope this is correct. 2 3 4 5 6 7 8 9. Okay, again if it is not 0, in that case this will work. The only difference is that instead of j we'll have this. Okay, yes, this should work. Okay, finally we'll have the answer. Why int answer? Since we are going from 0 to n, right, the final answer will be in n only. Okay, and we'll check every possible ending number, and answer plus equal to dp of n minus 1 I, and of course we'll mod it, and finally we'll do it like this. Let's okay. Fuck. Oh, sorry. So what is the issue here? Okay. Okay. Hmm. Let's see. अरे यार. Okay. Submit. Stream 48. This should work. Maybe. Oh damn. I mean the logic is same, so. Oh no, bro. I hate this question. Your task is to build a tower whose width is 2 and height is n. You have an unlimited supply of blocks. You have an unlimited supply of blocks whose width and height are integers. Here are some possible solutions for n is equal to 6. If we have n is equal to 1, then okay. Suppose we have n is equal to 1, right? In that case, answer will be this only. One way is this, and other way is we have a block of 2 cross 1. So we have the option of 2 blocks of 1 cross 1 or 1 block of 1 cross 2. 2 is the width and this is our height. Okay, so the DP state that we're looking for has to contain this information somehow. then again we have to factor the mirror images as well. So for n is equal to, the answer is 8. Let's try to build the answers for n is equal to 2. Okay, so we have this, right? We can have this, and we can have this, and we can have this, we can have this, and we have this, and we have this, and then we have this, okay, and we have this. So so how do we make this state? I'm not sure. Okay, so for every layer we have two options, right? We have two options. We choose a block of width 1 or a block of width 2. Okay, and in the next option we have a option of whether we continue the last block, right, or put a new block of our own. For example, this one here, at n is equal to 1 level we have chosen that 1 cross 2 block, right? So a block of width 2, And in the next level, when we went to the next level, we chose the option of not continuing the last block, but rather putting our own block, a new block. Okay, so in that case, we were able to make this tower. Similarly here, we had the option of choosing two 1x1 block, and the next we had the option of continuing it like here, okay, or placing a block of our own. In that case, we had the option of choosing a block 1x2 or two 1x1 blocks. So yeah, this thing. So if we look at the tree structure, okay, if we look at the tree structure from bottom, we have n is equal to 1 here. Okay, we had two options, this or this, right? And then we went to n is equal to 2 level. Then we had the option of continuing it. Okay, so also when we were continuing, we had the option of we can continue it, or we can stop it and put a block of our own, whether it is a 1x2 or 2x2. So yeah, this is how this, okay, and from this we have the option of from this we have continued it, right, or we did not continue it. So in that case it is like this. Okay, the fact that if we choose a 1x2, we have in continuing we also have two options. Okay, so this is not the only thing. We have the option of selecting which block to continue and which to stop, right? So for example, this is what we had, right? We can continue this, we can continue the right block and stop the left one. Okay, or we can continue the left block and stop the right one. Okay, so we have this when you want to continue, and also we have this when you put a 1x2 bar. No, when we continue from the like this, we can continue both the sets. Okay, so this is one node. I believe there should be one node from here also. If we stop it, I think this is it. The 3 to 5, 5 to 7. What else is there? 3, 4, 5, 6, 7, 8. Got this one. Got this one. Okay, so this is continuing, right? This is continuing the last block. This is continuing the last block. No, this is stopping the last block. Yeah. Okay. This is stopping the last block and putting a 1 cross 1 to 1 cross 1. And if we, instead of 1 cross 1, we can have a 1 cross 2, right? So yeah, this is another one. Okay, so we have these cases, right? Yeah, we have these cases to work through. This is kind of complex. Okay, for every ith location in DP, we have the option of continue last block, right? Or like start a new. Okay, so if we continue, so we have then also the option of which block we had in the which block we want to continue, right? If it is a 1 cross 1 block, then we have three options: continue left, continue right, and then continue both. Okay, if it is a 1 cross 2 block, the last block is a 1 cross 2 block, then we have only one option: continue both. We cannot stop one or okay. We want to start a new, right? So then again we also have two options. If it is a 1 cross 2, sorry, 1 cross 1 block, then we have the option of putting no, I think we only have the option of we only have two options then. Put two 1 cross 1 block or put 1 cross 2 block. Okay, so this is the hear some noises here and there. Okay, so in these subproblems itself, we can solve for the duplicates, right? So in the case of if you want to continue, in the case of if the last layer is two 1 cross 1 block, okay. So we have these three options, right? Continue left, continue right, and continue both. So instead of that, we can have continue one and continue both. I think. No. Or no. I'm not sure how to translate all this stuff into this DP state. I mean, I'm very close, but still not there. I think. do it. And with every tower, I think it will be multiplied, right? This will contribute to 1, this will contribute to 1, all of this will contribute to 1. DP state, what is the DP state? I know that we need the ith position, and we also need the width of the block, current block. Okay, maybe it is 1 or it is 2, so that way we can distinguish between the current block whether it is 1 width of 1 or 2. Also the fact that we have continued from the previous one. Okay, so true or false. We have not continued from the previous one. Three states I think is needed. The ith position. Okay, so let's just try to dry run it. I'm not sure if it is correct. Okay, so we have for n is equal to 1, we will have dp of dp of 0 1 true. Let's see, it's 2 is 1. Why? I don't know. We have 1 false. We have not continued it. It's a new one. And this will be 0, right? Okay, and then we have dp of 0 2. Fuck this 0. Same, we have continued it. This will be 0 because it is a new block, and we have this. This is for n is equal to 1, and it's also n is, and here n should be 1, but I don't know. I'll just go with it. This will be 1, so the total will be 2 only. Okay, yeah, and then for n is equal to 2, we have dp of 1. We put one block, okay, and we have continued it. How do I translate this into dp? Maybe I need to have the It's only solutions, bro. There's no one trying to explain this thing. Don't want the solution, I just want a little hint. Okay, I mean, we will also solve this ad code or DP contest, okay? I think this guy says that it will help build tuitions. We are very close, bro. But I just I can't translate all these things into this TP state. I'm not able to. I mean, am I close? I don't think. No. I think that I'm close, but maybe I'm going in the wrong direction. Completely wrong direction. Maybe. Okay. Okay. Let's just have a DP of I and J, right? And 1 second. I will show me the I will give me the level, and J will give me whether the last level I have whether I have chosen to link the last level or not. So a boolean, or maybe an integer value of 0 or 1. Okay, 0 means I have not linked. Yeah, this is actually I just glimpsed over someone's comment in Code Forces. So that is where I'm that is where this came comes from. So okay, 0 and 1, linked and unlinked. Then again, if it is unlinked, so that is basically we are not continuing it. So if we are not continuing it, there are then multiple answers. Okay, so if we have this at the top, okay, or this at the top, whatever we have, if we don't want to link it, then we have this option only, right? That we make separate we have this only. So basically we have 2 into dp of I minus 1 and unlinked, right? So yeah, unlinked. Or maybe this is unlinked. The last one is unlinked to its last one. Goods. CP algorithm have something. I don't want to look geeks for geeks, but okay. Let's just. This is not the correct one. Okay. understand, bro. Why is this like this? Why 4? Yeah, fuck it. Oh, oh, what an explanation, bro. Wow. So what this guy did was, okay, so this is like way too overcomplicated. Okay, so we have for n is equal to 2, we have these cases, right? We have this, and we have this, we have what this, we have this, and what else, we have this, we have this, we have this, and we have this. So again, here dpi, and then we have a, we can have a 1 or 0 type state, which will tell us whether the last, whether the, if this is the current one, then whether the last one is united, that is if it is a 1 cross 2 or a 1 cross 1 type of thing, right? So this actually also tells us that if there is a border between or not, right? So yeah, so if we see from one united block, one united square to going from one united squares to another united square, we have two options, right? We have two ways, and going from a non-united or two united, we have what? I think two ways as well, right? Or no, going from a non-united to united, we have one way, and going from a united to non-united, we have one way. Okay. Or basically, if this is the non-united, this is the united one, then reaching here, we can also add this in this, its contribution, right? The non-united one, and similarly from non-united we can add the united one. And going from this kind of, where all the blocks are non-united, right? Where the last layer of blocks is non-united, we have four ways. Okay, so transitions are like this: united to non-united. Okay, then we have united to united, and then we have non-united to united, and then we also have non-united to basically non-united. Okay, so in this case, when we have when we are going from united to non-united, so basically this thing, the dp for this, dp of ith non-united means 0, right, will be from United. Okay, because there is one way of doing that. Okay, the other one is United to United. So there are two ways of doing that. So dp of I1 plus equal to 2 times dp of I1 non-united to united. So basically we have one way only, dp of I1 plus equal to dp of I0, this case. Okay, final one is dp of I, this is non-united, we are going from non-united to a non-united type of square layer level. So it will be multiplied by 4, right? Because we have 4 ways of going from non-united to non-united. Okay, so we have a dp state. What is a dp state? That is number of ways to make the tower till ith layer given the last layer is united or not. I'm sure this is not the correct one, correct dp samples. Yeah, I mean it is similar. So we have our dp state, and we also have the transition. We need base case. So for dp of 1, dp of 1 0, what will it be? First layer, and we don't have the united blocks in the last layer, so it will be 1. Similarly, we have dp of 1 and we have united blocks, so it will be 1. So we have the base cases also. Base case we have the transition, and answer will be simply dp of like n minus 1, right? 0 plus dp of n minus 1 1, or if we have this can be like n also. Yeah, we can go with n. Okay, let's go. So we have the input, this one. We'll pre-calculate like everyone else did. Okay, so again we have our dp, this will be only 2, states, and n is going till 10 to the power 6. So yeah, 10 to the power 6. Again, we'll have t, and then we'll run the test cases. We'll have n, and then we'll just do it like this: 0 plus dp of n 1, and also we'll mod it. Yeah, so this should work. And the base case is we have 1, 0 is equal to dp of 1 is equal to 1, and for every other case we are building it from the bottom, right? So we can do it like this. We have where is the output? We can see that we are adding these, right? So we can combine these two and do it like this: dp of I1 plus equal to 2 into dp I1 plus dp I0. Okay. Similarly, we can have dp I0 plus equal to 4 into dp I0 plus dp I1. Okay, yeah, we can do it like this, and we'll just mod it at the end, in the end. Okay, so dp I0 plus equal to 2 into dp I0 plus dp I1, and this will be the last state. Similarly, dp I1, this is the united, this is the united case, right? Okay, green to green and green to okay. And then we have united from united, this yes, this, and we have dp of I minus 1 and united. We'll mod it. And let's see, should work. Think n was not declared in this scope. Okay, so 1e6 plus 1. Oh shit. I mean, it kind of worked. So okay, so there is a mod issue. Like, there is an issue with mod. In transfers, this one should not affect the answer anyhow. Okay. Maybe this. It's a mod issue. Mm, maybe we should not do it like this. Put this in this mode as well. Okay. I thought I had the macro set. I guess not. Okay, let's submit it. what was my last solution like? Okay, we have the option one of put either one width 2 or 2 width 1 tile. Okay, put, okay. Second is extend both width 1 tile. Extend both width 1 tile. Okay. Option 3 is extend one of the tiles. Okay. Option 4 is extend the width 2 tile. Okay. So dp of 0, that is. Are we solving from the top? Oh, we're solving from the top. Anyway, this the solution that we did was the easy one. Not easy one. It was easy to understand. I think the solution that we did. Okay, I did distance. Okay, we'll do this problem tomorrow. Today also we took a lot of help from other sources, and also I think how much the stream has been like 1.5 hours, and we only solved 2 problems. One of which was we already solved in the last class with some help, of course. So yeah, you can see that we have a long way to go. Actually, I have a long way to go. I don't think anyone is watching this, so yeah. But yeah, I think this, no, I can't say that I like nearly solved this problem, but I thought that I was in the right direction actually, but it turned out that I was overcomplicating things. Yeah. So yeah. So this is one of the pattern that I'm very weak at. Actually, this counting stuff, right? Counting, uh, you know, blocks, counting how many different towers, how many different uh, arrangements, and all that. I'm actually weak in that department. Also, yeah, we'll need to solve this one tomorrow as well, without any help, of course. And then edit distance, and I think longest common subsequence and rectangle cutting. Okay, so let's solve like 5 problems tomorrow to make up for all the time that we have not solved any problems for like 10 days. So yeah, and with that, it's finally good to be back after 10 days of sorts. Uh, yeah, we'll solve more problems this month, and see you in the next stream, I guess. Okay, bye. See you in the next stream.